Hey Year 12, righto, here's a new video looking at how to calculate the equation of a line from a table of values. Two things we need to find. We need to find the gradient, the y-intercept. Find the gradient by determining the change in dependent variable, that's going to be the bottom line here, usually a y, divided by the change in independent variable, that's usually the x. Alright, so it looks like this. M for gradient equals, alright, I'm going to use, I don't like negatives, I'm going to use these points here. So it equals the change in this bottom line, so that's 3 minus 1, divided by the change in the top line, that's 2 minus 1, so M equals 2 over 1 equals 2. Now we know that y equals mx plus b, that's what my equation is going to look like. I know what m is now, m equals 2. I'm going to substitute in some other points here so that we can find out what b is. Right? We're going to replace x and y with an ordered pair from our table of values. I'm going to use these points here again, just because they're a bit distinct. Any points that you put in though from that table of values are all going to produce the same answer. So I'm going to say 3 equals 2 times 2, right? That's y, that's m, that's x, plus b. So if 3 equals 4 plus b, b equals negative 1, therefore, right, first part of the answer, second part of the answer, right, our total answer is y equals 2x minus 1. Right, just like that. There are going to be 3 steps to doing these each time. Let's look at another example here. This time it's not x and y, but might as well be. Right, let's just treat it as though they are. Let's call that x and that y. This is my independent variable, volume. This is my cost. The cost depends on the volume. The cost is dependent, the volume is independent. Now, first of all, I need to find the linear formula, right, the equation here. So I want 2 points. Whichever ones we choose, it won't make a big difference. I like to use round numbers wherever we can. I'm not going to get anything that's that round, but I might go with, what do I like here? I'm going to go with this point and this point. Okay, so M is the change in dependent, that's 134.5 minus 109. I divide that by the change in this, that's 50 minus 20. Right, and if I calculate that, and when you calculate this here, you get an answer of m equals 0.85. You could leave that as a fraction, but because we're dealing with a modelling situation here, we're talking about real numbers, then we'll probably go with the decimal. There's m. Now I've got to find b by substituting points in, and I'm going to substitute these ones here for no other reason than it's there. So now I'm going to say, look, we can stay with x and y, or we can use c and v. So I'm going to say c, which is 109, equals m, that's 0.85, times 20, times 20 plus b. It's a terrible looking plus. There we go. Now, when we work this out, I get b equals 109 minus 17. Therefore, b equals, what's 109 minus 17? It's going to be equals 92. Right, therefore, my cost equals 0.85 times the volume plus 92. Right, we can confirm that's correct by substituting any other values in if you like, but we should be happy enough with the working. Right, it's a modelling situation. Let's look at what else happens here. What does the gradient represent? Right, the gradient represents the cost per kilolitre. Right, the cost per kilolitre. Right, every time the volume increases by 1, how much does the cost increase? What does the vertical intercept represent this particular case? Well, the vertical intercept is 92. That means if I use no litres of water, it still costs me $92. Right? That's like a service fee or a connection fee. Right? Or we could call that a fixed initial cost. That sounds pretty good. And finally, before we end this video, what is the independent variable and what does it represent? We've talked about this already. Right, dependent, independent, almost always the top line is going to be our volume, is V, which is our volume, which represents the number of kilolitres used. That's it. Righto. Check out the next video.